Hello. Uh, so this is a demo video of the project work that our team undertook in CSC573, that is Internet Protocols coursework at NC State University in fall 2016 semester under uh, the instructor Dr. Rudra Dutta. The aim of this project was to build a QoS enabled software defined network which would dynamically reroute the QoS traffic when congestion occurs and is detected in the system, or on, when there is a congestion between the best effort path. We have chosen a use case to demonstrate this by streaming two videos in our simulated network with congestion levels enough to affect the qualities of this video. So we would be streaming both the videos between same client and server combination. However, in one case, one of the videos will be marked as QoS traffic and the other video will be treated as a normal traffic. And we hence expect to see a better throughput for this QoS enabled or QoS marked video. Okay, so let's dive into it right away. So on your screen you can see that this is our topology that we will be using for this demo, and it is a slice that is created in Genie, that is Genie network, and the machines are arranged like this. So the OVS 1, 2, 3, 4 are the nodes which have Open vSwitch instances installed on them. OVS uh, is a switch in software, so it allows you to control it through remote controller, and hence the software defined networking comes into picture here. So as of now, when the controller is not running, so these OVS switches, they don't have any idea of how to route the packets or anything. So this is our private network that we can say, and at the edge of this network we have n number of hosts connected. So the discipline is that to OVS 4 we will have host 4 connected, and one of them for this particular use case we have our video server running on host 4, and host 2 will be a client that is going to stream this video. And we will be before we stream the videos we will introduce a suitable level of congestion so that the quality of this video should be affected. And we also leave a alternate path for the video to be reached from server to client in case the congestion occurs. So primarily we will be seeing best effort video, and then QoS marked videos. So here I have opened uh, two instances of VLCs. So the server is on host 4 and client is on host 2, and this pair of VLC is for the best effort a video stream. So now let us start the controller, and we have chosen Ryu controller, and once it gets starts, I'll be pushing up the addresses to all these OVSs using a REST API that is provided by Ryu. And now we have some multiple flows that have been installed in OVS 1 to 4, and let's come back to this a little later when we have actual traffic flowing through it. And okay, so here I have created some instances where we can generate some cross traffic. So there will be two streams, one flowing on this in the same path as of our video. This is from host 4 to host 2 we will be having a video stream, congestion, the traffic cross traffic stream and one cross traffic that flows from host 1 to host 3 to host 1 OVS1, OVS2, OVS3 and host 3. In this way, the best effort path, that is host 4 to OVS4, then OVS1, OVS2 and then host 2, will be pretty much congested. So let's first check if we have connectivity established. Okay, so we can ping host 4 from host 2 and let's start the cross traffic. For generating this cross traffic, we are using iperf. So we can see it's running on 5001 and from host 4 we are starting the cross traffic with bandwidth of 4.5 Mbps and let us say for a considerable amount of time. There we see a stream of cross traffic getting started, and okay, let's start one more stream. This is between host 3. Oh, sorry. Okay. Between host 1 and host 3. And this particular cross traffic is consuming bandwidth of 5 Mbps. Okay, so we now have a fair amount of traffic already in the network, and as we can see here in the controller, we are constantly printing the statistics of the flows of between all the switches, and here we are also printing the shortest path that are possible at that point of time between the switches. Okay, coming back to our video. Now, since we have injected the traffic, let us now start streaming the video. I have already configured the addresses, and the way we are going to distinguish between the QoS traffic and non-QoS video is through the use of destination port number. So in this case, we have used port number 5004 as a QoS for the criteria to determine whether the traffic is QoS or not. So this one is on 5000. This one is on 1234, the default port for VLC, and let's check that quickly. Okay, it is already there, so I'm not going to re-enter all the configurations, and I'm going to start this client first in the listening mode. So it now says started streaming, and instead of me running this stream directly and playing it here, I'm saving it in a file for later use, so that we can calculate PSNR on this video. And also one reason for doing this is the hosts that are in Genie, they don't have GPU, so we're not able to stream them as here and as and when needed here. So let me start the best effort video stream. So as you can see, here the timer has started, and this is a 2-minute 22 second long video. So meanwhile, let's go quickly to the flows that I have mentioned and see what all switches are carrying this traffic now. So If we go back to our topology, here is our server and here is the client. So either the traffic can flow from like this, from OVS4 to OVS1 through 2 and 4, or this path 4, 3, 2 and host 2. So we can check here at OVS4. Alright, so I can see that this flow has got hit, and what the rule says that traffic that is destined for 2.0 is going to go on output port 3, and okay, so let us check if that output port 3 was OVS1 or OVS2. I believe it is OVS2. Oh, sorry, OVS2 is going to be the end host, so I should have been checking at OVS1 or OVS3. Okay, so I see this flow getting hit, and it is getting constantly updated. So that means we have a running traffic for 2.0 subnet. So the path for this stream is this, like this: OVS4 to OVS1, OVS2. Just to confirm that we don't have any suspicious stream again going from here to host 2, let me quickly check OVS3. Here we should only be seeing the cross traffic that is from 3 to 1. Yes, so I can see the traffic going to 3.2, 3.2, and I guess the acknowledgements going back to 1.0. Oh, I guess this is only 3.2 all the way. Right, so now we have that when this cross traffic constantly running. Now let us start our QoS flow. So like I mentioned, we have port number 5004, that will mark the traffic as QoS, and just let us quickly check that. Okay, so here we will be receiving this stream on 5004, and first let me start the client on the listening mode, and now I'm going to start the stream. Okay, I guess I did not pre-configure it, so let me do it right away. So I'm going to pick up the same file that we used in the earlier best effort video stream. going to choose UDP. Since I've been using X11 forwarding, uh, th these VLC instances are running pretty slow. Yeah, one point of deactivating this transcoding is so that VLC does not intelligently change the bitrate and transcode it to a different format. We want the original video to be received. Yeah, we can see the stream has started, and let's go back to the flows. So now we assume that now the stream should take a different path, and now we should expect to see some flows in OBS 3.3 that direct some traffic to host 2, that is 192.168.2.0 subnet. As we can see, we have a flow added which was missing earlier, and that now is receiving some traffic, and it is marked, it is distinguished by a UDP and destination 5004. So we can now say that our QoS mark traffic is taking a different path in case of congestion. Meanwhile, let me transfer the first video that we had saved on host 2 to my host machine for streaming. So you can see that this video, we are receiving the QoS stream. It is not complete yet. If I run it again, we will have some differences. So that is still getting saved here. So let's copy this to my host machine. Yeah, I guess the video stream for QoS is over, and we now should have QoS video completely saved. Yeah, I guess you can see the difference in the size.
To be or not to be? That is the question. Oh, excuse me. Hello and welcome. My name is Big Buck Bunny. Indeed, you might know me from such films as Big Buck Bunny. Welcome to my home. Now just make yourself comfortable while I open this book.
Okay,
My
now we can
friends,
see that
let me tell you a sad
the
but true
congestion
story.
had kicked in
Did you
and
ever ask
the
yourself
video quality
what
got
happened to all those lovable
deteriorated. We can
characters
also see the
you see on
errors
the big screen when you were
where
young?
which VLC
No
is
matter
shouting.
what they might have told you in the movies, they didn't really get happily ever after. In fact, and as awful as this may sound,
Let
many of
me
them were
stop it
locked
right here
away.
and there, and let us stream the QoS video.
Or not to be? That is the question. Oh, excuse me. Hello and welcome. My name is Big Buck Bunny. Indeed, you might know me from such films as Big Buck Bunny. Welcome to my home. Now just make yourself comfortable while I open this book. My friends, let me tell you a sad but true story. Did you ever ask yourself what happened to all those lovable characters you used to see on the big screen when you were growing up? No matter what they might have told you in the movies, they didn't really live happily ever after. In fact, and as awful as this may sound, many of them were locked away in the deep, dark dungeons of Mount Copyright, only to be guarded by the terrible beasts we call lawyers. Unlike many of my friends, I was a lucky one. By releasing me under the Creative Commons Attribution license, my makers guaranteed that I at least would be able to enjoy a long and prosperous career doing what I love best, acting. This means I am able to be here with you for as long as you want and take part in new adventures, some of which even my
I guess
critics
this
wouldn't
is
have
enough
dreamed of.
and it speaks for
My
itself.
dear
So
friends,
I'm going to
let us
close
come
this,
together and make sure
and
that in the future
later
no
on I'll be posting the PSNR results of these two videos. But before that, even just by looking at them, it is quite evident that the QoS video got better treatment and it uh, it was transmitted with the least errors. All right. Thank you for watching.